Good morning, everyone. My name is Vibhor from Ego Foundation, and we are again restarting this session about DIGITx Bootcamp. This second session is on installation of Digit. In the first session, we learned how the architecture of Digit works and how do we design a service on Digit. In this second session, this will be conducted by Aniket. Aniket is a dual degree holder from IIT Bangalore and has been working on Digit for last 7 years. He leads DevOps as well as working on how to make Digit easier for our community to work upon. Now, in the next session, again, as I mentioned in the last session also, we'll talk about building on Digit. A new development is that we will be adding more sessions around UI of Digit, how to develop UI using Flutter and other tools. But those will be announced in due course of time, and you will know about those sessions before the next one on 2nd June. Okay. So I will not take much of your time. Just one request after the session, please do leave your feedback. If you have any queries, post it on the Q&A tab. If you want to interact with the panelists or other participants, you have a chat option enabled. All the best for the session. Aniket, over to you.
Thank you, Vibhor, for the introduction. So today's session will be on Digit installation. We will be doing a live installation of Digit and show how PGR module will work. So first of all, let me just define the scope of this session. So what we are going to do in this session. So first of all, we'll be provisioning infrastructure on AWS for Digit. Basically the hardware which will be required to run Digit, that will be provisioned. The second thing which we will do is do the basic Digit installation on that provisioned infrastructure. And next part will be seed data setup to get the application running. Okay. So as part of this session, we'll be only doing it on AWS, but we'll have a follow-up sessions for other cloud providers like Azure and also for SDC. Currently, we are in process of making the installation process easier for those providers as well. So I'll just move on to the next slide. So you must be familiar with this slide. Ghanshyam covered this slide in the last session. So this slide basically shows the overall architecture of Digit, like how services interact with each other. I'll just briefly explain it. For details, you can just refer the video of the last session. So basically, in this diagram, you can see there is an API gateway. So the apps which are above the API gateway are the client-facing apps. Yeah. Is it better now? Screen is not visible. Okay. Is it better now? Better now? Okay. Presentation is visible. Okay. Yeah. So sorry for the disturbance. So basically, the application which are above API gateway are the client applications like your front-end modules and all. And the application behind API gateway are basically your backend services. So whenever you log into any Digit front-end app, the API calls which happens to the backend will always go to API gateway, which has the auth and authorization integrated in it, right? So all the authentication and authorization will happen at the API gateway, and then it will forward it further to the appropriate service, right? And then this is the whole flow how it works. Like first the call will go to the service, then it will call the digit core services. Finally, it will publish the event on a queuing service. So we basically use Kafka for that, right? So I won't dive in details of this because it was already discussed in the last session. So before I start my presentation, I want to just explain a few things on whiteboard as to why we have come up with this architecture and what tools we use and what are the benefits of them. Okay. What was there? Okay. Yeah. So how does the overall flow work? So first you will have a developer, right? The developer will write some code based on the requirement. Okay. And once he write the code, he will push it to a GitHub site. Yeah. Okay. Sorry. Yeah. So basically, you will have a developer, right? The developer will develop some code and he will push it to github.com, right? Github.com is basically a site where you can store your code and it provides you with version control and other functionalities, right? So your code will go here on github.com. Okay. So now what's the next step? So suppose the code is tested and is ready to go to production, right? Or you want to deploy it on some server. For that, you will need to provision some machines, right? You need some physical machines to run this code on, right? So suppose what you will need are like some nodes for computation. Okay. And then some hard drives and some networking tools, right? Some networking tools, right? So what are the challenges you will face if you try to directly run this code on these machines? So first of all, like out of the call, whoever are developers, right, they can relate to this problem. When you try to run someone other's code in your local machine, there are a lot of issues with dependencies, right? So if you just try to take this code and try deploying in this nodes, you will have to install all the dependencies in this particular machines, right? And then again, it might have conflict with other code which you are running, right? So that creates a lot of problem and operational challenges. So what's the next step the developer can do? So basically the developer will try to package this code. I'll just remove this. Is it better now? Hello. Okay, thank you. So what will the developer do next? He will try to package this code in such a way like it can run. You can just run that package directly without any need for installing any dependencies and all, right? So there is a tool called Docker. You can use that uh, Docker tool to create something called Docker image. Okay. So basically, as the next step, you will create a Docker image. Docker image, right, of the code. Right. So now how to create the Docker image? So you will need something called a Docker file for that, right? So in that Docker file, you will mention what all dependencies you require, what all base image you want to use, and then you will add all of those commands in this Docker file. And once you create this Docker file, you will call a build command of Docker tool, right? And then that will create this Docker image for you. Okay. So once you get the Docker image, the next step will be to run this Docker image, right? So you will run this Docker image as a Docker container. Right. So once you get the Docker image, you will run it as a Docker container. Now, when you run a Docker container, right, it will have all the dependencies automatically installed inside that container. So you will have a running code directly in this container. Now it is fine to run Docker containers in a day or some testing environment, right? But when you go to production, you need a system which is reliable, right? Resilient, and it should be scalable as well. So only using Docker container, you won't achieve that, because if you need to scale more containers, then you will have to do load balancing and networking between those containers as well, right? So that becomes a challenge. Now to solve that challenge, there are tools available like Kubernetes, Docker Swarm. So I'll explain it via Kubernetes, right? So basically we will then use Kubernetes to run this container. So what Kubernetes will do is run these containers inside pods. Okay. Now to run these containers inside pods, you need to tell Kubernetes, right, how to run it, because you might need some X number of replicas. You might need some other features like monitoring, health checks, and all, right? So Kubernetes provides a lot of functionality. So uh, you will communicate that information to Kubernetes using Kubernetes configurations, right? Manifest, basically. So what is the journey now? So the developer will first write the code, push it to GitHub. Then he will have to package them into Docker image. For that, the developer will write a Docker file. And next step is to put those Docker images on a Docker orchestration tool like Kubernetes or Docker Swarm, right, which manages these containers, right? So for that, they have to write configuration for them as well, right? So he will write this Kubernetes config. Now, Kubernetes config itself is a complicated configuration, because as complexity grows, you will have to maintain multiple different configurations for a single service, because it will have a deployment configuration, a service configuration, an ingress configuration. So that becomes a problem in itself. So to further simplify this, we have something called Helm. Okay. Helm. So we use this Helm charts to manage Kubernetes configuration, right? So basically, it's a high level abstraction of this Kubernetes configuration. You can easily manage Kubernetes configuration using Helm. So it's a package manager basically for your Kubernetes configuration. So now your developer has to do three things, right? He has to write the code, then he has to write the Docker file. Okay. So anyway, like the developer has to do three things. Basically, he has to write the code, this code. Then he has to write this Docker file, and then at the end he has to write the Helm. Yeah, the Helm charts for that particular service. Once this is done, then your application is ready to get deployed in these nodes. Okay. So now coming to the next part, how to get these nodes and how to set up everything in this node, right? So basically, this architecture, infra architecture itself is a complex thing in itself, right? You need multiple nodes, you need to manage traffic to those nodes, then there will be networking component uh, uh, which will connect these nodes to internet. Then you will have hard drives, SSD hard drives to store the data which is getting generated, right? So this architecture, creating this infra architecture itself is a challenge, right? So to solve that challenge, we use some tools like Terraform, right? So I'll just okay, it's going down, right? Fine. Right. So now we need to get this infra, right, with nodes and hard drives, along with some networking tools. Right? So for that, we use something called Terraform. So I'll explain Terraform in my presentation. So basically, the DevOps person will, sorry. So basically, the DevOps person will write something called Terraform scripts. Okay. So those scripts will define all the physical resources which needs to be provisioned. Okay. So using Terraform scripts, the DevOps engineer will provision the infra for you. Okay, I'll dive in detail on how it is done. Okay, so basically this gets linked here. Okay, and once that is done, then he needs to deploy now the digit services on top of that, right? The whatever that presentation I showed before, right, where all these services are there, UI services, API gateway and backend services, those needs to be deployed on top of this, right? So that is done then using Helm charts, right? The Helm configuration which I showed above, this one. Using this, you can then deploy services on your infrastructure. Okay. So just one thing I missed out was on top, if you see, right, this phase where you convert from code to Docker image, this is basically your build phase. Okay. So this is basically your build phase. And this part where you take your Docker image and run them as pod, this is your deployment phase. Okay, so this part is called build and this part is called deployment. Now, if you are doing continuous development and continuously deploying the new builds on production or for testing, it will become cumbersome to do these things, right? To manually run those commands, and then there won't be any version control and lot of issues will come. Okay, so to automate that, you can use a CI/CD tool like Jenkins. Okay, Jenkins. So what it will do is it will automate this process for you, and then it will provide a lot of functionality like RBAC. Then you can see the logs. It will help you versioning and better managing of this thing. So whenever you can just go to Jenkins UI and trigger a build, right? It will automatically create the build and push the Docker image to a Docker hub. So as GitHub is there to store the code, you have something called Docker Hub to store the Docker images. Okay. Docker Hub is website. So basically, Jenkins can directly build and push your images to the Docker Hub, and then after that, the CI/CD, you can use the same Jenkins to deploy it to whichever cluster you want. Okay. Sorry for the drawing; it was a bit messy. Any questions on this part? How to get Git code from GitHub? How to create Docker image? What is the command? How to deploy using Jenkins? Or any other method. So, Varun, as part of this session, we will only cover the installation part. Anyway, I'll just briefly explain how it works. So, if you deploy Jenkins from the Helm chart, right? Jenkins is just another Helm chart. It has a Groovy scripts written in it. So, what Jenkins will do internally is it will clone this GitHub URL. Okay, it will it will call this GitHub URL and clone the code, and after that it has a set of steps written in it to execute the docker build command, and then next step will be to push to Docker Hub. So all of this gets taken care by a Groovy script. So I'll explain where we keep our Docker file and how they get built during slides. Okay, any other question? That, yeah, that I answered. So yeah, sorry, the last part was how Jenkins deploys it in environments. So basically in Jenkins Helm chart, you will have a CI secret.yaml file. I'll just briefly explain this part. So basically you have to give the Kubernetes configuration to Jenkins for your environment. So using that Kubernetes configuration, Jenkins will then call Helm to install that particular application, right? To deploy that particular application to your environment. I'll explain that part as well if required during presentation in detail. Okay, so moving on from this side, I'll just tell what is the high-level overview of Digit installation. So the first step will be to provision the Kubernetes cluster via Terraform. So in provisioning, I mean, you will get all the EC2 instances, your RDS database, along with a running Kubernetes cluster. Okay. The second step will be to preparing the deployment configuration. So deployment configuration is nothing but the Helm chart. So once you create an infrastructure, right, using Terraform, you will get the URLs, DB name, and volume IDs, all those details, right? Those details you need to add in your deployment configuration so that when you deploy, the particular service will know what volume it has to use and so on, right? So that's the second step. And the third step is to deploy all these Helm charts. Now, Digit has like 30 to 40 microservices, right? If you start doing it one by one, that will itself will be a time-taking exercise. So to make it easier, we have written a Golang based deployment script, which will basically refer to one YAML file and run all the Helm charts mentioned in that particular YAML file, right? So for today's setup, we will deploy backbone services. So backbone services are basically the bottommost services which even core services use, right? So they are open source services like Redis, Zookeeper, Kafka, Elasticsearch. Okay, and then we'll deploy gateway services like Zool, Nginx Ingress Controller, and then after that we will deploy our core services, which is Digit. Yeah, so these are basically, as I explained, the three stages of digit installation. In the first stage, from your local machine, you will run the Terraform script and create the infrastructure on AWS, right? For that, you will need a AWS account and you need to set the credentials on your terminal. Then once you run the Terraform scripts, it will provision the infrastructure for you and give you the relevant details. Is it not audible for others as well? Okay. So the second step is, once you get the details of your infrastructure, right? Like the Kubernetes configuration to connect with the EKS cluster, the volume IDs, the DB URL and all, you will put those in the Helm charts and then deploy the digit services on the EKS cluster. Okay, so that will be the second part. So that will again happen from your local machine. And this time you will be interacting with EKS cluster. Okay, so once the second part is done, you can do kubectl get pod. So kubectl is a tool, CLI tool of Kubernetes to see what is happening in your Kubernetes cluster. Okay, so I'll keep referring to it, kubectl. So basically, you can use that tool to see all pods that are running. So after second step, all digit pods will be up and running. Now, once that is done, there is one last step for the application to start, for you to start creating applications. Once deployment is done, suppose let's take the example of PGR, right? For PGR application to run, you need certain things like localization, right? What labels to show on UI, then what the workflow configuration should be for your PGR. So all these things are configurable. So before you start creating filing complaints on PGR or for in any other modules, right? You need to do a basic data setup for that particular module. So this third step, you will do that data setup for those modules. So in this step, you will be interacting with Digit APIs, right? So Digit services are already running as pods in your Kubernetes cluster. And in the last step, you will call Digit APIs to install, to insert the workflow configuration or localization data. Basically, all the seed data that is required to get the application in the final running state. Any questions on this part? Okay. Okay. So I have kept talking about Terraform, right? That is the step one. So what is Terraform? So Terraform is basically a open source tool which enables you to create infrastructure. Okay, so basically you will have infrastructure as code. Like, so suppose you have a AWS account, right? And you need to create a certain infrastructure. So there are two ways of doing it. First way is you go to AWS console, right? To AWS website, and then go inside and manually start creating your EC2 instances, then your databases, then your networking resources and all, right? So this is very error prone process, because if you miss a certain step, everything will be messed up and it will be difficult to debug, right? And also replication is very difficult in this, like to keep doing the same steps again and again in to create different environment itself is a challenging activity. So to simplify that, we use Terraform. So in Terraform, you can write infrastructure as code. Basically, you write the instructions on how you want the infrastructure. Like you want a case cluster, you want 4 computational units like EC2, then you want 1 database of RDS for Postgres. Like those you will mention in infrastructure as code, right? You will write those instructions in that. And then you can easily provision it using Terraform commands. And it's easy to create multiple environments using this, right? Because you just have to run the same command over and over again with different variables, right? So consistency will be there. You will get the same infrastructure every time. Okay, and also it provides a way of versioning things, like what is happening. It will provide you with versioning history and everything, right? So I'll just move on to the next slide. Also, one more point I missed was like Terraform supports multiple cloud providers like AWS, Azure, GCP, and all, right? So you can use the same tool to create infrastructure in any of the cloud service provider. This gives us a generic tool, right, which work across cloud provider. Also, you can destroy the cluster once the work is done. So that can be also very easily be done using Terraform, using just one single command. We'll showcase that as well in today's demo. So moving ahead, next is Terraform modules. So now once you create Terraform scripts, right, to manage it better, you create them in a modular way, right? Modular way means like even in our normal codes, right, we create different classes and then refer to those classes, right, in our main class, so that not to complicate things, right? So similarly, we do it in Terraform as well. We create a modular structure of the resources, and then you can reuse those modules wherever required. So I'll show this on VS Code, like how we have done it. So this is the last slide on Terraform. So what are the modules in Digit Terraform? So we have first a network module. So network module creates our VPC, private subnet, public subnet, all networking related things. Then we have a DB module. So DB module basically creates the Postgres RDS, which is required to store the data of Digit services. And then it will create a EKS cluster. So EKS is basically a Kubernetes cluster. So it's a service provided by AWS. Basically, they will manage the Kubernetes cluster for us. And then it creates multiple volumes. So ES master, ES data v1, Zookeeper, and Kafka are all name of volumes. So all these services require data volumes to store its logs and states, right? So for that, you need to mount certain volumes to them. So those are all are generated using Terraform script as well. So I'll just take a pause from presentation and show the Terraform scripts which we have. Any questions are there? Open question. Okay. So any Terraform script will have this 4 files: main.tf, output.tf, provider.tf, and variable.tf, right? And you need to run the Terraform command from this particular folder only. Okay, so basically you will have to cd to this folder and then run Terraform commands. It will automatically pick up these files and execute the instructions which are written in this file. So I'll first go to the the main.tf file. Okay, so what we have defined here in main.tf file, the first block basically tells you that we have a S3 backend setup. So I'll just quickly talk about remote state before that. So if you see in this sample AWS, we have 2 Terraforms. So one is inside of remote state and another is outside here, right? So why do we have this remote state Terraform? So what this particular Terraform script does is it creates a S3 bucket and a DynamoDB table. Now, why are this required? So when you create an environment, it will create this Terraform log and Terraform state file, right? These files help you to manage your Terraform script. So basically, whenever you want to update your infrastructure or delete your infrastructure or modify it in any other way, you can do using this state file. So basically, you will use Terraform command, but Terraform will require the states file to execute those commands, right? So they are very critical. So you need to save them at some safe place, right? So we first create this S3 bucket and Dynamo DB table using this remote state Terraform script. So once you create this bucket and DB table, they go as an input to this first block. So what it does basically is it tells Terraform that store your state files in this particular bucket. Okay, so whenever you run Terraform scripts, the state, right, the Terraform state will be stored in this S3 bucket. And now why DynamoDB is required is basically it maintains a state lock. So it might happen that two of your DevOps people are working on the same environment, right? And both are running Terraform script. So suppose someone is trying to add a S3 bucket and another one is trying to add a RDS or something, right? Parallelly. So what this does is it maintains a state lock. So only one DevOps person will be able to connect to that particular infrastructure using Terraform at a time, so that they don't overwrite each other's changes, right? So when you call Terraform commands, it will get a lock on the environment, and then you can run your commands. And when you are done, you release the lock, and then other developer can, or other DevOps person can get the lock and do his changes, right? So this should be there. It's not mandatory, but it should be there as part of good practices. Okay. The next block is network module. Okay, so you can see these modules, right? Module network, module DB. This is what I was explaining about the modular structure. So basically, in Terraform, if you go here in modules, you can see all these modules are defined, right? So all of this code, right? Instead of writing all this code in this single file, it's moved in this modular structure, and from there we refer it here in this main.tf file. Okay, so if you see this module network, right? So I'll just show DB1 because it's here. So basically, this particular thing you need to create for getting an RDS, right? This is a script to create a RDS and a subnet group for it. Now in your main.tf file, you will just refer to this module and fill all the values that are required to create that particular module. Okay, so instead of writing that whole thing here, we will just call this module here. Okay, so first one is network. Okay, so basically it's this module. So what it will do is it will create a VPC for you, then it will create a public subnet followed by a private subnet, then an internet gateway, then a route table. So basically it will take care of the overall networking infra that is required by you. Okay, so that's the first module, network, followed by DB. So this is basically, it will provision a Postgres DB for you. Okay, followed by EKS. So these are basically data. This data keyword basically calls the AWS cloud provider and gets this information, like what is the cluster ID of the EKS which you created, right? So next is this EKS cluster, which we need. So here again, so here you see the source is Terraform AWS modules, EKS AWS. So basically, this is not something, this module is not something that we have created here. We are directly taking module defined by AWS itself, right? And then here we mention our worker group configuration. So worker group basically are the machines, right? The nodes, computing units that you are running. So you can mention like whether you want Spot, then what instance type you want, how do you want them to override, then what is the max number of instances, what is the desired capacity, everything you can mention here. Okay, followed by then there is some security group rules to add to this rule. Basically gives your nodes access to your database, right? It's just a networking rule. And then followed by you have this volumes, right? I talked about how some services like Elasticsearch, Kafka, Zookeeper requires a data volume to store their data, right? So basically here we are provisioning a EBS volume so that we can attach them to those particular services. Okay. So yeah, so this is your main.tf file, right? And output.tf basically uh, uh, this whatever you add here, right, will be printed once the Terraform scripts are run, right? So basically whatever things you require after running the script, right? Like what is the VPC ID, what are my private subnet, what is the cluster endpoints, the Kubernetes configuration of the EKS, right? Whatever things you need to add it in your deployment config. That previously I talked about, right, about this, right? So once you do Terraform, you will get output from Terraform, and that output you need to add it in your Helm charts, right, in your deployment configuration. So to get that output, you need to mention it in this outputs.tf file. Okay. And this third file that is important is variable.tf. So here you must have seen this inputs which we take, right? Like the DB username, DB password, cluster name, whatever inputs that are required for this Terraform script, you can use, you can put it here in variable.tf. As I told before, you can use the same script to create multiple environments, right? So the only thing you need to change are basically this variable.tf, nothing else. So if you want to set up digit using Terraform, so just change this variable.tf and it will create a new environment with that particular name. Okay. So I'll move on from Terraform now. Any question? Okay. So this is the Terraform workflow. So basically these are the commands directly. So you just have to run Terraform init before. It will initialize the Terraform configuration. It will check if everything is fine or not. Then you can run Terraform validate. That is optional step. If for the first time during development, you can run Terraform validate to see if syntactically and internally it is consistent or not. Then you do Terraform plan. So Terraform plan basically tells you how it is going to create the infrastructure. So it will, in the output, it will print everything like what all resources it is going to create and all. So step 1, 2, and 3 don't actually create the environment. They are just for you to see if everything is fine. Finally, when you do Terraform apply, that time it will start creating those resources on AWS cloud, right? So when you do Terraform apply, your local Terraform script will start provisioning those resources like I showed, right? Network, DB, EKS. So all of this will start getting provision from Terraform apply after running Terraform apply command. Okay. And once you are done with your environment and you no longer need it, then you can just call Terraform destroy command. So this command will then start destroying, means it will decommission everything and it will delete all the resources that you have provisioned. Okay. So that was the Terraform part, basically how to get the infrastructure, right? Once you get the infrastructure, then you move to the code part, right? How to deploy services, how to build services and stuff, right? So first, we will discuss why we use Docker, right? So I already explained in the diagram what are the advantage of using Docker. So first one is basically isolation and portability, right? So isolation is like all the dependencies which are required to run your code, right? They will be inside that container. So whenever you want to deploy it in some other environment, you can easily do it without any need to install anything or uh, upgrade anything, right? And then the second thing is consistency and reproducibility. So basically, you might have heard this problem like it works in his machine, but it's not working in my machine. So that's the thing with consistency, right? So because of different dependent version of dependencies, sometimes code might run in your local, but it won't run in your friend's laptop, right? So Docker takes care of this consistency, right? Because it packages everything in itself. So you don't have to worry whether it will work or not in other machine. It will work as it is working on your machine, right? So it provides this consistency and reproducibility of functionalities. And then third is efficiency and resource utilization. Now, what is the alternative to Docker, right? Means suppose you want to isolate, you can create VMs, but then virtual machines, that is VMs, will then have his own operating system, which itself is very heavy, right? So that's not very efficient if you want to run, suppose, hundreds of Docker images. So Docker works on the host kernel itself, host OS kernel. So that is way more efficient than VMs, right? So basically, it's efficient and thus optimal resource utilization. The next thing is it's easy to scale. Now you have one Docker image running, you can just scale it up to 4 or 5 or however you want, right? It gives you that flexibility. And then it's fast and consistent development workflow because you don't have to worry about dependencies and whether it will work in other systems or not. Developers can quickly just develop stuff and ship it out, right? So its development becomes faster because of it. And then it provides versioning and rollback. So whenever you create a Docker image, you can version it, right? It's versioned basically. So suppose you created a Docker image and it has some major bug and you need to revert or roll back it, right? You can always just go and deploy the old image, right? So because of versioning, it's easier to roll back in case of any issues. Okay. So moving on, the next tool I wanted to discuss is Kubernetes. So as I showed that last step of my diagram, right, from container to pod, right? So there was this issue of managing Docker containers, right? It's difficult to manage them manually, right? So you have Docker orchestration tools like Kubernetes and Docker Swarm available to do that for you. So we'll be talking about Kubernetes in this session. So basically, what it helps with. So it takes care of many things. It provides you consistency, right? Like it will make sure that at least like whatever the number you set, right? At least minimum that number of replicas of your pod are running or your containers are running. So suppose something goes down, right, because of some issues, then it will automatically spin up a new pod for you. So Kubernetes provides you with this consistency, right? And then there are a lot of other things which it provides, like it's easy to monitor. Then it provides you with load balancing functionality. Basically, it will distribute the loads between different containers automatically for you. Then you can do updates to your pods as required. Then automatic scaling and self-healing I already talked about, right? That you can automatically scale, and then also if something goes down, it will automatically try to get it up back, right? And also there is lot of community support available for Kubernetes, as it is very widely adopted tool. Okay. Moving on, Helm, right? So I talked about Kubernetes, and then you need to write Kubernetes configuration, right? To tell Kubernetes on how to manage your Docker container. So Kubernetes configuration itself is a complicated thing. So basically, to get one service up and running, you need to write around 3 to 4 different configurations, right? So it's difficult to manage. So we use Helm instead. Helm is a package manager for Kubernetes configuration. So it provides lots of benefit like reusability and modularity. So basically, you can keep a common template and use it across for all the services. Then templating and configuration. As I said, like if you put a common template, you can just change the few variables, whatever are required using the template engine which Helm provides, and it's easy to upgrade and maintain. Basically, you can pull different Helm charts using help command and upgrade as required, right? And it also provides dependency control. So basically, you can mention like to run this particular service, what all dependency needs to be there, right? So Helm has a lot of benefits. So before moving to the architecture part, I'll show how our Helm charts look like. Okay. So in our folder structure, this is infra as code where we store Terraform script, and then config as code is where we store our Helm charts. Okay. So in Helm, you can see there are in config as code, there are two folders. One is environment and second is Helm charts, right? So in environment, you mention you can overwrite values which you want to overwrite at environment level. I'll just first explain Helm charts, then I can explain you how they get overwritten in environment files. Okay. So let me just take any sample Helm chart first. Okay, let's take indexer for example. So every Helm chart will have this 4 files in it. So first will be sorry, these 2 files will be there and template will be there. Okay, so chart.yaml will basically hold the metadata about that chart, like what version it is, what app version is running, and what are the dependencies for this particular Helm chart. And then you will have a values.yaml. Values.yaml basically is the file where you overwrite values. So all of your charts are basically in this templates. Okay, so all of your Kubernetes configuration is in this template, and the values for that configuration gets overwritten in values.yaml. Okay. Now, if you go to any template, right, you can see there is only this common.deployment required. Now here, this part of reusability comes into picture. So if you see any of our Helm chart, right, any other Helm chart, you will see in templates, it refers to common.deployment or common.ingress, right? So here we are not explicitly writing the whole Helm chart again and again, right? We have defined a common Helm chart, and then we are just referring to it in all the services. Now tomorrow, suppose you develop a new service and you want to add it as part of your deployment, right? So the Helm chart part, right, where I said like the developer needs to create a Helm chart for the service he has developed. So basically in Digit, he just have to copy any of the folder and just make changes to this chart.yaml, like just the name he needs to change here, and then in values.yaml. So in values.yaml, basically he just needs to override the values whatever he wants. Okay. Any questions on this part? Okay. So I'll just show one sample values.yaml file. So these labels are basically just the app name which you want to show. Then you will have a section called ingress. So in ingress, I'll come to this part later. I'll have to first explain what ingress resources are. Then I'll come back to this part. And then here you mention about init containers. So init containers are basically the containers which run inside the pod when the pod initializes. This again, I'll explain in detail in some time. Okay. Then you here mention the image, which image basically you want to run, like from which replica, from which repository. And then you mention the replicas. Now replicas are basically what are the number of pods that you need to run, right? Suppose certain service is getting used heavily in your application flow, right? Then you need more replicas of that particular service. So you can just configure here. Or suppose like you have dev environment, right? In dev environment, you don't need many replicas. So accordingly, you can set the replicas, right? And then you need the health, you need to add the health checks. So as I said, right, Kubernetes keeps monitoring if the service is up or not. If it's not up, it will automatically try to start new container. Now how Kubernetes does that is basically it keeps calling this health endpoint of each service, and you need to mention it here. So you just need to mention the context path and /health here. Okay. Then all these other things you can keep at as it is. So basically you are just mentioning how much heap space you want, what are the arguments you want to pass while running the application and all. Okay. And then these are the environment variables which you need to override. So in the next session, next Friday's session, which is a development session, you will come across a file called application.properties in the Spring Boot application, right? So basically, whenever you develop a module, you will have a application.properties file, which contains set of variables which are configurable, right? The variables which will change from environment to environment, right? So they will be something like your DB username, DB password, then your internal services host and all, right? So those needs to get overwritten. So you can add them here in this environment section. So suppose tomorrow you write some custom code in Digit, right? And you need to control it via some flag. If that flag is set to true, then you should run that logic. And if the flag is set to false, then you don't run that logic, right? So that you need to code first in your application, and then you can just add an entry here, like one more entry here. Okay. And then you can just control it using this Helm configuration. Okay. So this is like one particular chart. Okay. Now I told like everything gets referred from a common Helm chart. So this is the actual charts. Okay. So all other services are just referring to this chart, and they are just overriding the values in this chart using this values.yaml. So values.yaml doesn't have any Kubernetes configuration. Okay. It's just overrides the values in this common template. Okay. So in common template, you can see there is this deployment.yaml, right? So this is the actual Kubernetes YAML, right? And all these things are basically Helm. I told about Helm has templating in template engine, right? So these are Helm related annotations. So based on the values you put in values.yaml, right? These conditions will execute, and your final Kubernetes configuration will get generated. Okay. So if you need to change something in all the pods, right, this is the place where you will do. So suppose you want a different type of deployment, or you need to change something in your ingress. So if you change here, it will start reflecting everywhere. Okay. And similarly, in this common, you have a values.yaml, right? So these values.yaml are the defaults. Okay. So this will be applied to all the services which are using this common template. So basically all of the Digit services. So tomorrow, suppose you need to change something here, like you need certain variables to be changed across all services, right? So there are two ways of doing it. Either you can keep going inside all of these services and then keep adding it in values.yaml, or else you can just add it in this single place in common values.yaml. Okay. So if you add it here, it will be reflecting in all the services which import this, which uses this as dependency, basically all of Digit services. Okay. And the final value which gets overwritten will be of your services values.yaml. Okay. So the hierarchy goes like this. First level is values.yaml in common. So you can overwrite here. Okay. But if suppose you override that value in your services values.yaml, that will take preference. Now there is one more level above it. Okay. That is basically this environments.yaml. So Helm charts are for services, right? Now you define Helm charts. Now, as I said, like your DB URLs and those things will keep changing from environment to environment, right? So it's not a good idea to keep going in these services and keep changing them, right? Instead, better way to do is to leave this as it is and create another file in which you can configure environment specific things, right? So basically we have this environment.yaml and environment.secret.yaml. So ego-demo is just name of the environment. Okay. So you will have this particular file, and this is the one which has the top priority. So whatever you put here will overwrite everything. Okay. So suppose you put something in the services values.yaml, but you put a different value in here, right? Then it will pick up this one. So whatever you define in your environment.yaml will be the final value. Okay. Now I'll just quickly explain a few things about this environment.yaml file. So here basically you mention the domain, right? What domain you want. Now again, this is same as values.yaml. Okay, there is no Kubernetes configuration in this as well. So here mentioning what values you want to put in your Kubernetes configuration. Okay. So the first section here is domain, right? So all these are placeholders, and during deployment, you will see like all these placeholders will be replaced with proper values. Okay. So basically the website URL will go here. Then, as I said, Terraform will give certain output, right? Like DB host, DB name, DB URL. So those things you need to add here, right? And then this service host and everything will remain same. So these are basically the uh, internal host for calling other services. Okay, so you don't need to worry about this. Just one thing, like if you create a new service and if you need to call that service internally, then you need to add an entry for it here. Okay. So this is the common configuration. And after that, you can see here service specific configuration is also added. So basically for ego file store, you need to override this in particular environment, right? So you, suppose tomorrow you create a new service called voter registration, right? So you just add this here, okay? And start adding the variables here, like the variables which you have in the values.yaml of your service, right? So it will override for that particular service. Okay. Any open questions are there? Okay, I'll move ahead then. Okay, so Helm I explained. So still there are many things like config maps, secrets and all in Helm. I guess you could just go over the Helm charts and try to understand them. And if you have any queries, you can just post it on our discussion board. I'll be happy to answer them. So there are a lot of components in Helm and I've just covered few of them. So next is the overall architecture. So once you do this Terraform apply, right, this is what gets created in the AWS cluster. So basically here is the region, right? So you need to define a region in which you are deploying. So for India, we deploy in AP South 1. So similarly, you will have geography based regions, right? So you can select the region in which you want to deploy. So that will again be part of this variable.tf file which I showed, right? So this specific VPC, right? The networking component will be deployed in that region. And then in that you will have a private and public subnet. So all of your database and your nodes will run in a private subnet, while the load balancer. Yeah, I guess one more is added now, not sure. So yeah, so private subnet. So you will have your nodes and IDs running in private subnet, and your node balancer will be load balancer will be having a will be running the public subnet. Okay, and now how this resources in private subnet can access the internet is via this NAT gateway. So NAT gateway allows only one-way traffic. Only from internal, it allows traffic to outside. From outside, you can't connect to the internal services. So it's one-way traffic. So it's for security purposes. So only when this services, right, when your machines want to connect with internet, they can connect with internet. But from internet, no one can connect to these machines directly. Okay. So NAT gateway takes care of it. Internet gateway is basically to give internet access to your overall VPC. Okay. Yeah. And basically, on this left-hand side, you can see the Amazon EKS, right? So basically, this is EKS control plane. This is Kubernetes as service provided by AWS. So we are provisioning that as well using Terraform scripts. And then at the bottom, you can see that we have a S3 bucket and EBS volumes. So S3 bucket you need for your logos, or suppose file store service you can configure with S3 bucket. So you can have this S3 bucket to store those things. And then these are the E volumes which are required to store your Kafka logs, Zookeeper logs, ES data and stuff, right? From infra perspective, that's all. So I just wanted to discuss few critical components. So first of them is cert manager. So in our Helm charts, you can see there is a service called cert manager. So what cert manager does is it automatically uh, generates a certificate for your domain and provides you with SSL certificate management. So basically, whatever domain you have, right? That domain you will open as a HTTPS, right? So that domain you will basically from that client to the backend service, it will be a encrypted exchange, right? So that happens using this SSL TLS protocol, right? So for that you need a certificate. So that cert manager takes care of these certificates, right? And Digit cert manager is configured to connect with Let's Encrypt. So it will get this free certificate, and it will automatically renew it when it comes near expiry. Okay. So cert manager is already integrated. It's already integrated with Kubernetes Ingress, and if you want, you can integrate it with external issuers. But currently in Digit, it's only integrated with Let's Encrypt, which is a free certificate provider. Okay, and cert manager will help you with multi-tenancy support as well. Like you can do multiple multiple subdomains certificate management easily with cert manager. Okay, so just a few pointers related to cert manager. Cert manager issues certificate based on annotation in your ingress YAML. So I'll show that 1 second. So as here you can see, this is a ingress. Okay, so let me just first quickly tell you about ingress. So ingress is a resource of Kubernetes. So you can see the ingress in your Kubernetes cluster by doing kubectl get ingress. I have just added an alias for it, ki. So when I do get ingress, I get all these ingress rules, right? So what ingress does is it basically tells Nginx. Nginx is our load balancer, right? Ghanshyam explained it in previous session. So it will basically route from Nginx to the appropriate service, right? Like how Nginx will know to which service to forward this request, right? So Nginx knows this using this ingress resources. So I'll just show this one ingress resource. So in this ingress resource, you can see there is this annotation, right? certmanager.io/cluster issuer, let's encrypt -prod. So because of this annotation, cert manager will know that it has to create a certificate for this particular ingress. So what it will do is it will look at the domain name, this host that is there, and then for it, it will get a certificate for this particular host. Okay. And then once it get the certificate, it stores it here in this secret. Okay. So we have this secret name defined here. It automatically does everything. So it will automatically scan this ingress. It will see what is the host. It will automatically generate, get the certificate and then store the certificate as a Kubernetes secret, okay, under this name. So this is all automatically handled by cert manager. Now suppose tomorrow you don't want to use cert manager and you have your own certificate, right? Like from some other vendor or something. So what you need to do is just go to the root ingress. Okay. So root ingress is basically with a path slash. So basically I'm saying if someone just goes to the domain name, right, without any context, then you route him directly to the service called citizen. Okay. So you have to go to the root ingress and then change this secret name to whatever secret you have with that, with your personal or your vendor certificate. Okay. So basically, first you need to create a Kubernetes secret using your certificate. Okay. And then that secret name should be overwritten here. Okay. Then all the communication will happen using the certificate which you have added. Okay. So I'll just show one other ingress. So now this is the ingress for PGR, right? Now here you can see there is no cert manager annotation because we already have certificate at the root level. We don't need at the subpaths, right? Now here I have defined like if call comes to /pgr-services, you forward it to Zool, right? So you must have seen that diagram where all the services gets routed via Zool, right? So this happens using this ingress rule. So whenever you create any new service, right, three Kubernetes resources get created. One is deployment, then second is service, and third is ingress. So out of that, this third one, ingress, basically tells Nginx to which service to forward the request to. So all of our backend services gets forward to Zool. Okay. For UI service like this one, you can see it directly goes to the pod instead of going to the gateway. Okay. So related to cert manager, if you face any issues, right? So if you're running an old version of cert manager or something, you might face issues with auto renewal. So just be careful when you try to debug it. So suppose basically cert manager will create another resource called certificate. Okay, it's a custom resource of cert manager. If you keep deleting it, right, it will keep trying to get new certificates for you. And since there is a rate limit, after if you try more than 5 times, your domain will be blocked for 168 hours or something, right? For 7 days, you won't be able to get certificate from Let's Encrypt. So just be little careful when dealing with this component. So the next thing which I wanted to discuss, application service discovery. So now, so I told you now how Nginx knows where to forward the call, right? So basically from ingress resource, it knows I have to forward this particular call to this particular service. On presentation, it has changed the slide. Just 1 second. Now it came. I don't know. Okay, sorry. So yeah, so we were talking how Nginx knows where to route the request, right? Now the next thing is how Zool will know where to forward it. So as you know, all of our backend requests are sent to Zool, right? So using ingress rules, all of our requests to our backend services will be routed to Zool. Now Zool should know, after doing its authentication and authorization checks and enriching correlation ID, Zool should know where to forward it again, right? So that happens using this Zool Kubernetes discovery. So it's basically a utility which is written by us, and it runs as an init container. So let me just explain what init container is. So last time I showed how container runs inside a pod, right? But you can have multiple containers running inside a pod. So it's not a one-to-one correlation, it's many-to-one, right? You can have many containers running inside of pod. Some containers you can keep running for the whole time, while some container runs only when the pod starts. So they are called init containers. And if you would have noticed in values.yaml, you could have seen there we mention init containers and then write flyway or GitSync, right? So those things we run as init containers. So basically, whenever a pod start, that piece of code get executed in that container, and then it switches off, right? And then your normal service starts. So Zool Kubernetes discovery is one such init container which we have created. So what it does basically is it calls Kubernetes API to get all the services. Okay, so it will call the Kubernetes API to get all the services, and then it will see for which services that Zool is set to true. So you could have noticed in values.yaml, under ingress there was one field called Zool, and you could set it to true or false, right? So if you set it to true, that service becomes discoverable by Zool. So when this Zool Kubernetes discovery starts, it will call this Kubernetes service API, get all the services that are running in the cluster, and for whichever service that flag is set to true, for that it will create a mapping. Okay, so Zool works on Zool maintains this mapping, like the URL to which service to forward to, in a file called routes.properties. So like ingress, this is another file. So that file is basically in this module Zool. Okay, so it's a route.properties file. There you mention that if it comes to /pgr-service, it should be routed to pgr services pod, right? So Zool works on top of this route.properties file. So what this Zool Kubernetes discovery does is it will dynamically start generating that file. So whenever you deploy Zool, Zool discovery will create this route.properties dynamically, and then Zool service will start, which will use this route.properties to figure out where to forward that particular call. Okay. So if you sometimes develop new service and deploy it, right, you might get 404 not found. So that is because Zool is already running, right? Zool doesn't have this record of this new service which got deployed. So in case if you deploy a new service, you need to restart Zool for this reason, so that this init container runs again. It will create that entry in its route.properties, and then you will be able to connect to that service. So whenever if you face this 404 issue, try restarting Zool. It can be your service issue as well, but just check the route.properties inside Zool pod to make sure. Okay, so next thing I wanted to discuss was Sops. So this is basically a tool, secret operations, the full form of it. So basically, we use this tool to encrypt whatever data we keep in our ego-secrets.yaml. So I showed this environment files, right? So there are two files in that. One is environment.yaml and second one is environment secrets.yaml. So environment secrets.yaml will have the values which are sensitive, like your DB username, passwords, your Git SSH key. So all the sensitive information will be stored in this secrets.yaml file, right? Now, when you push this configuration to GitHub, you cannot just push your secrets without encryption, right? Because then it will be visible to everyone. So you need to encrypt it before. So for that, we use this sops command. So you can see there is a .sops.yaml file in the folders. So in that file, you need to mention which key you want to use for encryption. So as I mentioned in the slide, you can use multiple keys and then use any one of that key to decrypt SOPs. So basically, if you want to use KMS key, you just add ARN of that KMS key. If you're using PGP key, that entry. So I'll just show one sample.sops.yaml file. Yeah, so this is one such file. So basically I'm saying like for this regex path, right? The file which matches this regex path, you use this KMS key and this PGP key to encrypt it. Okay. Now that encrypted can be decrypted with any of this key, any single one of this key. Okay. So moving forward, we come to GitSync. So I think like this is another critical piece. So you must have seen like whenever you put data on MDMS, right, in GitHub, you need to restart that MDMS service. So this is due to how it works. So we use this GitSync container. So GitSync again runs as an init container. And if you need to clone any code, right, inside of your pod, you can use this container. So you can look at MDMS service or persister service or any other service which uses this. In its values.yaml, you can see how to define this particular init container. Okay, so what this init container does is when the pod starts, this gitsync container will call GitHub, okay? And basically it will take the GitHub URL as the argument. You will define it in your values.yaml, okay? So when the pod starts, the gitsync container will clone that particular repo completely in your containers file system, okay? So like you have in your local when you do git clone, right? Similarly, it will clone and keep that particular data or those files in the containers in your pods file system, right? And then any other service which wants that data can directly use that part to access that data. Okay, so that's how MDMS, persister, indexer, all of these services work. And in installation, you will see there is a part where you have to add a private and a public key pair. So why that is required is due to GitSync only. So basically in GitSync, you need to add a private key. Okay, so GitSync will use that private key to communicate with GitHub to authenticate itself using SSH. So basically in your GitHub account, you will add your public key and then GitSync will use its private key to verify itself and clone the GitHub repo. Okay, so if you if your MDMS pod is in crash loop back off or have some issues, right? It's mostly because of that SSH key. And if your MDMS service is down, it will have a cascading effect on all other services because many services are dependent on it. So please make sure during installation that you have proper key setup done in your secrets.yaml file. So Shashwat will show it during live demo how to add and where to put that private key in our secrets.yaml. Okay, so uh, so this is now the last slide. Yeah. So the last part I said is seed data setup. Now, why do we need seed data setup? So basically, once you get your PGR service up and running, right, the APIs has the API, the PGR API will internally call workflow service to initiate the workflow, right? And workflow service basically needs a workflow configuration to work on. So all these things has to be pre-configured before you can start using the PGR application. So for that reason, we need to add a few things. So PGR workflow configuration is one of it. Then localization messages for the UI. So basically on UI, we just have placeholders, and depending on the localization messages we add, those text will appear on UI. Okay. So for that, we need to add localization messages, and also you need a root user, right, to create other users or to access APIs. So this root user, the first user will be a super user, which we will create by port forwarding, because Zul won't authenticate anything, any other API, right? Someone has, yeah. So that's all from my side. Someone has raised hand. Can you just type otherwise? Hmm? Can you please speak, Bikash?
Prakash, we have allowed you to speak. If you can unmute yourself and speak about your concern. We see your hand raised.
Okay, so we'll move ahead. So now we will proceed to live installation. Okay. Okay, so we'll continue with a live demo. Yeah, I'll stop presenting. So Shashwat from our dev team will be doing a new setup of Digit, and he'll show, he'll install Digit, and then he'll show how to like one flow of PGR service. You can start sharing your screen. So, yes, we are recording the session. You can start, right? So first. Okay, so we'll start. So as I said, like there are some prerequisites that needs to be installed, like Terraform, Helm, and all, right, to on your local before you can start the actual digit installation. The prerequisite document was shared. So already on Shashwat machine, those prerequisites are installed, and he has set the AWS credentials as well. So you need the AWS credentials to connect with the cloud, right? So you can Google it, how to set them. It's available on AWS site as well. So there are certain uh, restrictions, I guess. You can try, but I'm not sure whether it will work. Okay, so the first step is to uh, uh, clone the repo, right? So all of our infra is code, right? Our Terraform scripts, our Helm charts, everything is in this particular repo. So the first thing will be to clone that repo. So just one more pointer, whichever folder you are cloning in, right? Just make sure you don't have space in the folder name. So sometimes it might have some, it might cause certain problems. Okay. So once that is done, you need to check out this particular branch, git checkout digit bootcamp. So for now, we have pushed our automation in this branch. We'll soon merge it in master as well. Okay. So next step is to just cross check whether the AWS credentials are correctly configured or not. Right? Okay. So it's not there. So he'll just export it. Okay, so now you can see like he already, so whenever you install this AWS client, right, it will create a .aws folder in your home directory. In that .aws folder, there is one credential file. In that credential file, you can add those AWS credentials. And then using this export AWS underscore profile command, you can set those as the default credentials. Okay. So moving on to the next part, this third point is what I was explaining about GitSync containers. So if you have MDMS crashing, then this might be the cause. So there are two ways in which you can generate the SSH key. So first one is like online, but of course it's not recommended for production. And second way is you can use OpenSSL commands to generate the SSH key. Now for demo purpose, we'll just get it online from this site. So there will be one private key and one public key. Now public key, you need to add it in your GitHub account. What? You can use whichever you want. Okay, so we have added the public key. Now the resultant private key we will add in the secrets file. You can just follow document steps. Okay. So next step is to go to this input.yaml file and add the variables name. So these are basically your cluster name, what name you want to give to your DB, those variables. So here also you need to give that public SSH key. So this key is basically the one which you want to put in your EC2 instances. So you can just use the same key, or if you want another pair, you can change this as well. So this key, the corresponding private key will be used to connect to the EC2 instances directly using SSH. So there are some validations on DB name, DB username, right? So these are AWS validations. So I already added what validations are there, like contains only alphanumeric character. Then on cluster name, there is like cluster name can have only lowercase alphanumeric character and hyphens. So please follow those validations. Otherwise, this might fail. AWS might throw an error. digit.org. So we already have a domain digit.org. So we are just adding a subdomain so that we can add it in our GoDaddy account. So you can use any domain provider you want. So next step is to edit the secrets YAML. So here basically you'll have to add the private key and the DB password. So please keep the password and the flyway password same. So they are actually getting used interchangeably. We'll remove one of it later. So we have added the private key. Just cross check everything once before running the next step, because the next step will start replacing these values in the placeholders, right? So I have shown you the placeholders in variable.tf and in egovdemo.yaml. So this next command will basically replace the input.yaml values in those files. So yeah, so you can see the output of this command. So it's saying variable.tf remote state, variable.tf main.tf, environment YAML and environment security YAML file updated successfully. So we have placeholders in all these files. So rather than going in each file and replacing, we are just taking the inputs in input.yaml file, and this script basically replaces all those placeholders. So next step is to create that remote state bucket, right? So I talked about how Terraform state gets stored in a S3 bucket, and logs are maintained using DynamoDB, right? So next step will create that infrastructure. So now it's initializing the Terraform configuration. Okay, so in plan, it has shown like what things it's going to provision. Now it's doing actual provisioning, and it has now provisioned the S3 bucket and Dynamo table. Now we will do the actual infra provisioning for digit. So this will require 10-15 minutes since it's a heavy operation. So once we start Terraform apply, we can take a break for 5 minutes. So please copy paste your password directly from here. If they mismatch, your pod will go in crash loop backup state. So regarding file store policy, there is a document just parallel to this stage. You can just refer to that. Just check what name you have given. One second, we'll just check what is this issue. Hello. Yeah, sorry for the glitch. So we tried it multiple times yesterday. It was working, and today suddenly AWS in their response changed this particular. Can you showcase this variable? So yeah, so what issue was like this output, right? I explained what output we should get from when we execute the Terraform script, right? So uh, what happened now was till yesterday, AWS DB instance.rds underscore Postgres dot name was returning the DB name from AWS side. Now today suddenly it's not working. So we checked the documentation and we have to use DB underscore name instead to get that output from AWS. So we have made that changes and did Terraform apply now. So we are the Terraform applies running. So basically Terraform is now provisioning infrastructure on our cloud account. Okay, so our infrastructure is now provisioned, and this is basically the output of it. Just scroll up and show the whole output. So basically, as you can see, we are getting the instance name. The username is not visible because it's sensitive. Then we got the volume IDs and the Kubernetes cluster configuration. Now we'll follow the next steps. So now the next step is to enrich all these IDs in your deployment configuration, right? So we have an automation script which will do it for us. So Shashwat will just run that script now. So we have executed that script. Now we just need to set the cluster configuration. Sorry, the kube configuration. So you just need to copy that command and execute it. So since it's a window shell /r inverted, so Shashwat will just correct them. Okay. So now we have set the set check nodes. So now we have set the kube config. Now we can see if nodes are available. Yeah. So now you can see that nodes are also available. So these are basically the EC2 instances which are provisioned, right? And our EKS cluster is now controlling them. Now we have completed our provisioning step. Now, next step will be to deploy digit services on this EKS cluster. So you need to cd to the deployer folder and then run the Go script, which will iteratively go through the Helm charts and execute them one by one. So it will ask you like whether you want to proceed. Then you can have multiple multiple Kubernetes configuration in the same file. So you will have to select which one you want to run. So we'll run this one, EKS Aniket demo. Okay, so we'll select digit next. Yeah. And we'll install the digit 2.7 version. And for this demo, we'll choose PGR. So we are just selecting the environment file. So ego-demo is name of that environment file, which you can see left-hand side. So once we select yes, it will start executing the Helm charts. So we have got some issue with Sops. We'll just check it 1 second. Yeah, so sorry for that. So there was some minor Sops configuration. So we will correct it and push it in the repo itself. So now you can see what services are getting deployed. Now we have deployed the services. It will take some time for the pods to get up and running. So as you can see, they are initializing. So in the meantime, I'll add the CNAME to the in the domain service. So Shashwat, just ping me the CNAME. Just show first how you get this. Yeah, so basically, this is the CNAME. So I'll just add it in our, I'll map this CNAME against our domain. So I've added the entry of that CNAME in GoDaddy against the domain which he specified. So we'll have to wait for 5-10 minutes for the changes to take place.
So we'll have to wait for 5-6 minutes till pod gets up. So we are waiting for the pods to get ready. So it will take some time for when you do the installation. So once all these pods are up, we'll add seed data. UI is up now. Shashwat, you can just show them. So you can see now there are placeholders now instead of the actual names. So once we add the seed data, this placeholders will be replaced with actual text. Okay, so now most of our pods are up and running. So we will now start adding the seed data. We need to first import this postman collection. Basically, it has all the curls which you need to execute. First, we need to port forward this particular user service pod to create the root user. So once we do port forward, we directly connect to the pod from our local host. So it will bypass Zool. So Shashwat has called this create new validate API to create the root user. So now we will use auth token of this root user to create other, to call other APIs. Yes, you can run. So basically, this is the OAuth API. This gets called when you log in the screen, right? So we directly called it via API. And then we are taking this access token to now use the other APIs. So you need to change the domain name, of course, to it should point to your cluster. So now in the next step, we are now inserting localization. Since we are adding a lot of localization, it will take some time. Okay, so we have inserted the common localization. Now we need to add two more, locality and PGR localization. So now we have added all the local. Now we just need to add the workflow configuration. Yeah, so we have now added the workflow configuration as of now. We will just try to create one application. Okay, now you can see like proper text have started coming here. Okay. So first we will register one citizen in the system. So since we didn't add SMS credentials, for now we will take the OTP from logs. In production and all those environments, it's disabled. Only in bootcamp, we have put this image where log is added for user OTP so that we can add it here without SMS integration. This is done for bootcamp. In production builds, this won't be there. You won't be able to see the OTP anywhere. So now we have logged in as a citizen and we'll just file one complaint. So we are just not filling any mandatory things since you need to configure all these things in your secrets.yaml file. So we are just filling the mandatory fields and moving ahead. Okay, so now the citizen have successfully submitted his complaint on PGR, and now we can see the complaint in employee. So Shashwat will now log in as an employee. So now he's going to log in as an employee, which he created using the Postman request. So you can see this complaint which got created. So yeah, so this is just the flow. Now he can go inside the complaint and take whatever actions are configured against this. Now, since we have not created any user, we can't assign it to any other user. The only thing we can do is reject the complaint. If you have all the setup done, then you can assign it to other users and do things. Yeah, now he has rejected the complaint. So yeah, this is the just a small flow of PGR. Still, you need to configure file store. You can configure it using S3 bucket or some other storage. There are documentation for that. We have not done it in this demo. You can just follow the documentation and do the same. So we have got the basic digit setup done. We have got PGR application up and running. So there were a couple of glitches which were not expected. One of that was not in our control, but second one we could have managed better. So we'll do the correction and push the updated scripts on the same branch. Sorry for the glitches. Any questions are there? Okay, Shashwat, can you just show how did you configure AWS? So, one second. Yeah, so basically, these credentials you will have to get from AWS site and then put it here, okay, in .credential file. So that is basically in your home registry. There will be one .aws folder. Inside of this .aws folder, you have to put it in credentials file. Okay, you have to put it in credentials file, and once done with that, you have to go to the terminal. Okay, and do export aws underscore profile and the name of the profile which you have given in that credentials folder. Yeah, this in mode. How collection specifically? What? About the Postman collection, but whatever shown, they're asking where is that. Yeah, so it will be there in the release notes of each module. So this one was for PGR. With each module, we publish what workflow default workflow configuration is there for that module. This guy already replied. So I guess Nikhil already replied to that, around 700 to 800 rupees for per day for this demo setup. So now we will just destroy the cluster. Yeah, so since we are not going to use it, it's better to destroy it. Otherwise, that recurring cost will come. So please make sure once you are finished with your demo, you as well destroy it if you are not going to use it. So you just have to run one Terraform first, delete your Nginx load balancer. So this command is required because load balancer is not created by Terraform, but by your Kubernetes EKS service. So that's why first you need to run this command. It will delete the load balancer resource from the AWS. And then you just need to delete, do Terraform destroy to destroy the rest of the infrastructure. So now load balancer is deleted. We just need to go to sample AWS and do Terraform destroy. Sure, we'll add it. We'll send it out. So basically, it just listed what all it is going to delete, and we have to confirm. Yeah, so Docker images are already there in the release chart. So finance module we will cover in a different section, since it's not completely microservice based. So now it's destroying all the infrastructure which we have created. This reply 1.2. Just reply to him. Hello, Shashidhar, actually, I have created a Docker image. So I'll publish it by end of next week mostly. So you can just exec into that Docker image and then use Docker dashboard terminal or directly from your terminal to complete setup. So you don't need any pre-installed CLIs or anything at all. Any other questions are there? So please feel free to try this same. We are facing the error by deployment. Yeah, you can please post your queries on the discussion board. So we will reply on that. So we were a bit occupied with this setup. So you can expect reply on the same day for your comments on discussion board. Shashidhar, you can contact us. We have so for now you can contact us on through a discussion board only. You can tag us personally, and we'll see if we could open up a Slack channel. We'll add you. We'll send a link out for that. For now, you can communicate via discussion board. We'll share it. Vibor will share with everything. So I'll create a separate installation video as well. We'll share that also.
Other questions?
Thank you, Shashidhar. Sometimes issues might come during Terraform destroy, and the rest of the things you might have to do it from console. Generally, it works, but it's not something in our control completely. We'll just check with Vibor and get back to you, Steve. So we'll share another recording also with of installation. We'll explain everything in more details and clearly. So you can just follow that video as well if you want to try Digit. So all the scripts are there in that same repo, and you can add whatever output you want in your output.tf. Thanks, Manish. Yeah, Krishna. So sorry, I saw your first issue, and I guess Nikhil replied on it. For second one, I was a little bit occupied with this thing. So yes, it most probably will be a GitSync issue. Also, just see if you have added the proper public key in your GitHub account.
Hi guys, this side Vibor again. Thank you, Aniket, for the session. We face some challenges as happens in any of the technology programs or a technology application. So I think that's part of life. But those are the things that requires continuous improvements. There are a lot of system dependencies, external dependencies that keeps on happening. We'll see you guys next Friday with Build on Digit session. This recording of this session will be made available through our YouTube channel. There is a Digit by Eager Foundation YouTube channel, which has channel YouTube at digit-dpg. Digit_dpg. Previous sessions recording is available already there, and this session's recording will be made available soon. Keep an eye there. Do leave your feedback. As soon as the session ends, there will be a pop-up for feedback form. You can again, engage with us on our discussion forum. You can access the discussion forum from our core platforms documentation site, core.digit.org. Thank you very much. Have a nice day and following weekend. Thank you.